So friction helps us to write. Friction helps us in a lot of other ways. If you have seen some conveyor belt in any industry, suppose there's a bottle coming here, a robot came and put the bottle here, and due to the motion of the belt and the friction between the bottle and the belt, and as the conveyor is moving, the belt is having some velocity in this direction, and due to friction, the bottle gains that velocity. And automatically the bottle would come here, and another robot or machinery would be there to seal the bottle, and that's the whole process goes. If friction wouldn't have been here, then the mass transfer on a conveyor belt or any other mechanism like this would have not been possible. Okay, so that's a brief introduction about the benefit of the friction. And of course there are some disadvantages of friction, but the advantage is so high so that it actually discounts the disadvantages. And one of the major disadvantages, it results in mass loss, because as per our previous discussion, friction invariably causes mass loss, because friction causes the loss, the breaking of the teeth and the peaks that we were discussing. Two surfaces get interlocked, and for them to move, these teeth have to break. There is no other way out. So whenever two bodies are in contact, there will always be mass loss if they are rubbing each other. That's the only way they can move on each other. So friction causes mass loss. Over the period of time, you have to change the parts of machinery. You have to change your shoe, your slipper, the wheels of your vehicles. You have to change all of them because they are rubbing the ground. But that's okay. If there would have been no friction, it would have been a difficult place. This world would have been a difficult place to live in. So mass loss is the only way we can work our things out. So that's the introduction to friction. Now we are moving to numericals now. So let's start solving some problems. Suppose a truck is carrying some good. The good weighs 50 kg. The truck is moving with acceleration of 2 meters per second square. Now the question is, what is the direction of friction force on the 50 kg block, and what is its value if it's given that the good is not slipping on the surface of the truck? They're moving together, so how much is the friction force acting on the good and in what direction? So the whole system, the truck I said is moving with 2 meters per second square, and the good is not slipping. So the whole system is moving with 2 meters per second square. So the good is also moving with 2 meters per second square. And have you read Newton's second law of motion, F is equal to ma? So force, you can calculate from here, that force would come out as 100 Newton. Now this force is the horizontal force which is causing the horizontal acceleration. So this force must be friction force. The friction force is the only force that can act horizontally in absence of any external force. So friction force value should be 100 Newton. In what direction? Friction opposes relative motion. Suppose there is no friction. Whenever you have been asked in which direction the friction is acting, or you're thinking in which direction the friction is acting, always go this way. Suppose there is no friction, then what would happen? The good will remain here and the truck will slip forward. Is that what's going to happen? Right. So if the truck is moving forward, now suddenly suppose there is friction starts acting. If suddenly the friction starts acting, then what will friction do? Friction will oppose the relative motion. The truck is moving forward, and the only way to oppose the relative motion is to take the good also forward. So the truck is moving forward, the good also moving forward, then there is no relative motion, there will be no rubbing on the surfaces. So the friction on the 50 kg block will act in forward direction. So the friction force could be given as 100 Newton I cap. You can get the direction like this. So this is the friction force acting on the good. This is A, this is B, this is a rod, and block A is attached to the rod so that it just lay on B and it cannot move forward. It is constrained to remain here. It cannot have any horizontal motion because of the rod. Okay, the mass of A suppose is 100 kg and mass of B suppose is 200 kg. The friction, the coefficient of friction of the contact between A and B is 0.2 and the coefficient of friction between B and the ground is suppose 0.3. And the question is, what minimum force do you require to be acting horizontally on B so that B moves relative to the ground and A?